Hello everyone. Welcome back to learning. Today, we will talk about a function that is commonly used together with the defined function, the earlier function. It is mainly applied in scenarios involving cross-row calculations, and learning and using it as one of the more challenging functions in FindBI. Before we dive into the learning, let's first look at a simple case as an introduction. We have a field with months and a sales amount field where we need to calculate a cumulative value. In FindBI, you can achieve this effect easily with quick calculations, but since we're talking about earlier today, we'll use it to implement this calculation. It's very simple, so let's see how earlier is written. We use defineAdd function and inside, we write SUMAGG, but in the last parameter, we use order less than or equal to earlier order as the syntax. First question, why do we use SUMAGG for cumulative calculations? Actually, you can understand that when we calculate the cumulative value for the first row, it's just the sum of the sales amount for that row, which is 100. When we calculate the cumulative value for the second row, it's the sum of the first and second row's sales, 200. Similarly, the third row's cumulative value is 300, which is the sum of the first three rows. Essentially, it's still a sum aggregation of the sales amount field. However, cumulative value calculation involves using earlier for cross-row calculations. Earlier serves as a filter condition for such special calculations, which you can think of as a filter condition that applies to specific rows. Second question, why is the formula written as order less than or equal to earlier order? The answer is that earlier in the function represents the current row. So, it can be interpreted as order less than or equal to the order of the current row. For example, for the first row, the serial number is 1, so the filter condition becomes order less than or equal to 1. This means only the first row is considered, and the result for the first row is 100. For the second row, the order number is 2, so the filter condition is order less than or equal to 2. This includes the first and second rows, and the result is 200. The same applies to the third row, which includes the first three rows, and the result is 300. So, earlier serves as a dynamic filter condition that allows us to perform calculations across rows. Now, let's move on to a conversion rate analysis example. If you remember, in the first defined course, we discussed conversion rates where the denominator was fixed at 39,521. Today, we will add a little complexity by calculating the conversion rate based on the previous node. For example, for the first node, the conversion rate is 33,008 divides 39,521. However, for the subsequent nodes, like the delivery amount of 107, the conversion rate should be calculated as 107 divides 1,111, where 1,111 is the number for the previous node. How do we calculate this? You can take it into consideration. Alright, let's jump directly into FindBI. You can access the data directly via the hyperlink in the PPT or search for the earlier function in the help documentation, where you'll also find this kind of example and can download the data. Looking at the current data, we can see that the customer numbers for each node are available, but we notice that the rank number is missing. For example, let's assume we have rank like 1, 2, 3, 4, 5, 6. With that, my logic becomes clear. Customer number in rank 6 divides the counterpart in rank 5, customer number in rank 5 divides the counterpart in rank 4, and so on. How do we add this rank number? There are many ways to do it, and adding it directly to the data is possible. However, since we're discussing earlier today, we'll use earlier to implement it. I'll quickly write this function and then discuss with you why it's written this way. Now, I've written it. The most difficult part to understand is why I use COUNT-DAGG on the key nodes. What does this mean? If I count the key nodes for the entire table, the result will definitely be 6, because there are 6 nodes. But here, I'm using COUNT-DAGG function just like we used some for cumulative calculations before. However, there's a filter condition. The customer number should be greater than or equal to the current row's customer number. What does this mean? For example, when I look at the store visiting row, its rank number should be 2. When counting, we notice that the customer numbers greater than or equal to the current rows are the first row and itself. So, with this filter condition, only these 2 rows are considered, and we get a result of 2. Similarly, for the order node, with a customer number greater than or equal to 1111, it includes the 5 nodes above it, so the count will be 5. This effectively achieves a sorting effect. When you drag this into the view, you might encounter a small issue where the result isn't as expected. The reason is that I used the original customer number from the detail table for calculation. But what we need is the aggregated customer number from the view, not the raw data from the detail table. So, we need to define a function to return the total customer number for each key node. It's not complicated, I use the define function to do this. Now, after replacing the customer number field with the new one, we see the correct sequence from 1 to 6. After calculating the rank number, let's think about how to calculate the conversion rate. It's quite simple. For example, when the rank number is 2, I wanted to return the customer number for rank 1. Similarly, when it's 4, I wanted to return the customer number for rank 3. The pattern is just the current row minus 1. Thus, we can write another defined function using SumAGG for the customer numbers, and set the filter condition to ensure that the rank is 1 less than the current rows. This is the number of customers in previous node. After that, we can calculate the conversion rate by dividing the current row by the previous one. We can also change the data format to percentage. Finally, after sorting and verifying, the conversion rate looks correct, and everything seems good to go. This is how we complete the scenario. Okay, let's go back to our PPT. Now, let's give another operation question. For this operation, you can click the 2 hyperlinks in the PPT to download the corresponding data and refer to the help documentation. Let's look at the requirements. The requirement is to return the sum of the current month and the previous 2 months' sales for each row. Let's first understand what this question means. For example, I have a summary of sales for each month. In March, I want to see the sum of sales for the past 3 months, which would be January, February, and March. Similarly, in July, I would want to see the sum of sales for May, June, and July. This is essentially a simplified version of a common business scenario. It can help us better analyze the continuous sales growth trend of the company, which is more scientific than looking at monthly data alone. Now, let's look at the calculation. First, I lack an index number, right? After adding the index number, the next challenge is defining the filtering conditions for what we want and how to write it using earlier. It should include the current row plus the previous 3 rows. Let's turn it into a choice question. You can see that the core of this function is the earlier part. You will notice that it's different because it involves both a greater than and a less than condition, so I can frame the data between them. Please pause the video and think about which option, A, B, C, or D, you should choose. Okay, now let's reveal the answer. The correct answer is B. Why? If we're not sure how to write it, let's look at a specific row, for example, row 3, March. According to the requirement, the sum of sales for March, February, and January is needed. To break it down, it should be greater than or equal to 1 and less than or equal to 3. So, for the current row, it's the sum from row 1 to row 3. For March, row 3, the range will be greater than or equal to 1 and less than or equal to 3. The logic here is, earlier helps us to calculate the previous rows, including the current one. Thus, the correct syntax is earlier for both the greater than or equal and less than or equal conditions. So the answer is B. Does this logic make more sense now? The earlier function is something that requires practice to fully master, so I recommend using it for your own data analysis, like calculating month-over-month comparisons. However, for general use, it's usually more efficient to rely on the built-in quick calculations to save time. Now, after all this learning, I'm sure you can master the define function.